Thank you so much, Eustace and Jeske and Ashley and everyone, all of you for coming. It's really quite an honor to be here to give this talk. You know, when I was asked to reflect upon the past, present, and future of computational social science, I thought it was a really good idea. And then I sat down to write the lecture, and I realized it either means I'm the oldest person in the field, which I'm not very happy about, or it means I have the hubris to try to define the field by myself. And I don't want to be either of those things today, so I'll try to avoid both Scylla and Charybdis, and start out by letting other people and technologies define the field. So let's start in the present. And right now, in fact, at this very minute, these three students are experiencing a lecture at the University of Calabar in Nigeria. And the lecture is on something I know nothing about, which is machine learning and epidemiology. And they are amongst a cohort of young scholars who have been recruited from all over sub-Saharan Africa to help define the future of our field. When Eustace mentioned that these events, which we call the Summer Institutes in Computational Social Science, are principally to provide free training in education, that's true. But the other thing we do, which is quite intentional, is to create and encourage lateral connections among scholars, very diverse groups of people across disciplinary divides, so that they can define the research agenda, and we give them money, small amounts of money to start projects, some of which I'll be talking about today. Okay, so I would love to take the pulse of everybody that's part of this wonderful community I've had the privilege of being a part of for a long time to answer the question, what is computational social science? But instead I'll have to do the parlor trick, which is to ask ChatGPT. And it, you know, as it often does, gives a fairly reasonable response, right? Computational social science is an interdisciplinary field that combines elements of social science with computer science and computational methods to study and analyze social phenomena, human behavior, and social systems. It leverages the power of computational techniques and large-scale data analysis to gain insights into complex social processes and patterns that are often difficult to study using traditional methods alone. I actually don't have too much to add. It's not a bad definition. I'd probably give it a B+. You know, like most things ChatGPT, it's good but not great, right? We'll talk more about that when we get into the future of computational social science. So I think a more conventional way to define this field would focus on two very, very well-known factors that nobody who was foolish enough to attend a long lecture about computational social science doesn't know already, which is that there's a lot of data out there. So this is a graph showing the increase in the zettabytes that have been created worldwide. And there's just one data point that I love, which is that in 2014 alone, more data was collected than all previous years of human history combined. That was a pretty stunning statistic when I first heard it. And now we've surpassed that 3, 4, 5, 6, 7 times. Not anything revolutionary for this crowd. I'm sure you'll also know that there's been major advances in computing. Many of you will be familiar with Moore's law that predicts sort of linear or growth in the size of computing power in CPUs, now GPUs. As we can see, up through 2020, that's been progressing. And so we have more data, we have more powerful tools to analyze it. But one of the fundamental things I want to try to convince you of today is that computational social science is just not a set of methods and data, but is really advancing the theoretical agenda of the social sciences. And I think that's most clear when we start to look at sort of citation analysis. A lot of exponential graphs today. A lot of stuff's increasing, including the number of citations that use a set of keywords. I don't have time to go into them, but you'll have to trust me that they roughly approximate the field. Things like computational social science, big data, human behavior, and so on and so forth. And as you can see here, we've seen a marked increase in the number of terms in fields as diverse as business and economics at the top there, computer science, unsurprising, psychology, and down towards the bottom, my own discipline, sociology, though even sociological citations in the field have pretty much exploded. The field is also really densely connected, more so than I think a lot of interdisciplinary fields. The field, I would argue, is necessarily interdisciplinary. Many of the questions we want to ask and answer require insights from multiple disciplines. So here, as you can see on the left here, these are individual papers, and the edges between them in this network graph describe citation patterns, and a community detection algorithm has been used to cluster them according to similarities in the citation pattern. And so you can see there's a cluster of business and economics, there's frequent engagement with geography, with communication science, and with psychology and many other social sciences. And yet there still are some fields and disciplines which are sort of at the margins. And we'll talk more about how I think we need to pull those in later in the talk. I suspect there's a few sociologists in the crowd, so I wanted to briefly point out there's a really diverse group of questions that motivate computational social science within sociology. So here we're using some natural language processing, specifically the term frequency inverse document frequency, which is a sort of a metric that we use a lot in NLP, or natural language processing, which is designed to pull out the words that are sort of uniquely define a set of documents within a corpus. So as you can see here at the bottom, we have sort of good old-fashioned social network analysis, but also a lot of work on agent-based modeling, a lot of work on social movement, a lot of work on gender, demography, economic sociology, the sociology of medicine. Indeed, when my colleagues and I did a review of this literature 2 years ago, we discovered it's sort of spread its tentacles into most every field. We also see public interest in the field growing steadily, maybe not quite as exponentially as it is in academia, but still pretty significant. So here we have the Google search volume. These are sort of, this is relative search volume, so it's not normalized against anything that would allow us to make sense of the raw numbers here. But essentially, you see a pretty reasonably well-growing trend. And there's some good news and some bad news, right? As our science has entered the public sphere, we've done both good and bad, and I think it's an example of a current dilemma in social science that we'll come back to. But I think an indicator of the health of the field is that most major universities now have a set of scholars who identify as computational social scientists. Not all of them have a computational social science program, so well done to Uwe. But we're well represented in many of the most powerful parts of the university. Okay, so how did we get here? Here's what I do, the old man thing. All right. So I was thinking about and reflecting about how people join the field. And a theme in this lecture you'll notice is I'm going to mostly talk about other people, and I'll briefly indulge in a little bit of autobiography that I hope will help illustrate some of the different pathways to the field. And I think most people can sort of be placed on a continuum that ranges from sort of theory to method, and whether they approach the field with fundamentally theoretical questions that they need new methods to solve, or whether they are, an innovator on the methodological side and they're in search of a theoretical puzzle that these methods can address. And so I have a very unconventional path to computational social science. And one thing that is maybe unique about me is I started off as a deeply qualitative scholar. My advisor, I think many of you will know, is Michel Lamont, who I think was visiting here some years ago. And her advisor was Pierre Bourdieu. And as a young graduate student, I was extremely motivated by questions about meaning making, specifically how groups of people attach meanings to social categories, and more importantly, how those spread broadly in a society. And so Bourdieu was a revelation for me. Many of you will recognize this graph from his opus Distinction, showing how cultural tastes can sort of cohere into different pattern groups, which then when we overlay them on the social stratification system, we discover how cultural interests reinforce and create various kinds of social hierarchies. And so I was just sort of intrigued by the idea that you could study meaning from 30,000 feet, as I like to say. You know, most scholars in this tradition were pursuing deeply inductive, remarkable and wonderful research that uses in-depth interviews, other sort of historical methods, principally to identify how meaning is created in situ in social interaction. But I was always hung up on a line from the sociologist Anne Swidler, who said, I think I'm gonna mess it up, the greatest unanswered question in the sociology of culture, which is a subfield that sort of deals with this, is how certain cultural elements anchor and constrain each other. And so, you know, thinking about culture as a system of ideas that has a kind of systems level logic was something that motivated me throughout my academic career, especially in graduate school. And I somehow found myself interested increasingly in texts, and there's a long tradition of qualitative analysis of quantitative data. And I found myself in a workshop with the political scientist Gary King, who was one of the early innovators in bringing natural language processing into social science. And suddenly I discovered a remarkable toolkit that really allowed me to ask many of the questions that I thought were impossible to answer. So I would say, I would identify as someone who's principally motivated by theoretical questions, who was sort of like, okay, I need a new tool, I'm gonna go learn the tool. But the other common pathway, and I'm sort of generalizing here, of course, this is sort of a typology, is the people who get excited about gradient descent, right? Are there any of those people here? No? It's okay, you can no judgment. I like gradient descent. Okay, so, you know, here, there's a long tradition in social science of sort of, I would argue, fetishizing quantitative methods, and you know, a lot of work in the observational realm, trying to simulate experimental conditions with observational data. And along comes machine learning and just blows up everything, I would argue. You know, everything from causal inference, still a long way to go there, but specifically pattern recognition, which was, of course, very important to those of us who were interested in natural language processing and especially identifying patterns in text, which is something that I did for at least the first 10 years of my career. And I don't present these two pathways to say that one is better than the other. In fact, one of the core arguments I'll make today is we need to just sort of do away with this sort of typology, in large part because of the advent of generative AI and how I think that will level and inspire a new dialogue between people who come from both traditions. Okay, enough about me. Back to the community. And as I was reflecting on how to tell the story of the past of computational social science, I realized, you know, what better way to reflect the wondrously diverse you know, interests and talents of the community than to talk about the program that I mentioned at the outset and that Eustace mentioned, the Summer Institutes in Computational Social Science. So we started this program back when everybody called it big data. Remember big data? Anybody remember big data? Yeah, that was a thing, yeah. Probably anybody under 22 might not know that. I don't know, anyways, another old man joke. Anyhow, computational social science was just coming into the scholarly lexicon. And I was then an assistant professor on the tenure track. And for those of you who are young, that's a stressful part of a scholar's career. And the legendary cultural sociologist Paul DiMaggio approached me at a conference. He said, how would you like to organize a summer school? And I nodded my head and smiled because Paul's amazing and you just say yes when Paul DiMaggio asks you to do anything. But in my head, I was like, this is crazy. I've never organized a conference. You know, who am I to teach, you know, to influence the young minds here? And he's like, great, you'll do it. And I guess I nodded and smiled. And anyways, somewhere on the other side of the conference, he was doing the exact same thing to my dear friend Matt Selganek, who's another sociologist. And you know, the interesting thing about the pair of us is that we approach the field from entirely different directions. So as I mentioned earlier, I was on sort of the theoretically motivated side and he was more on the methods side. I think he would self-identify in that way anyways. And so it was sort of an awkward idea. You know, we were both sort of like, oh, is this gonna work out? And we started talking and discovering all sorts of interesting points of overlap between our own work and we sort of talked each other into doing it, which was pretty cool. But nowhere near as cool as the first time we started looking at the applications for this program. So the Russell Sage Foundation, which is a small American foundation, does a really cool thing. It decided long ago that in new fields, there's a strong need for training where it does not yet exist in the university system. And so they recruit people to set up these summer schools, and they're supposed to run for 2 or 3 years until the sort of fields mature. Things like behavioral economics was one of its legendary programs, social genomics. And so the plan was we would do this for 2 or 3 years. And most of these programs get 40 applications, 50 applications, except 30 people. We got 360, and this was all the way back in 2017, again, before the field was really even defined as such. And the most magical moment was simply getting these 30 people in the same room. It was effortless. I'm going to talk a lot about the careers of some of these people to sort of illustrate trends in the field in a bit, but suffice it to say these are just really brilliant people who, all we did was bring them together in some sense. We challenged them through lectures on everything from machine learning to natural language processing to web scraping, most importantly maybe ethics, mass collaboration, and additionally, and I think more importantly, with the benefit of some distance, we let them do research together. So all we said is during the second week, we're going to try out a process that I had tried in my graduate seminar at Duke, where I was teaching at the time, still teach. And the idea is it's called speed dating. Research speed dating, not speed dating, right? Research speed dating. And the idea is that everybody sort of fills out a list of interests in a Google Sheet. Really pretty unsophisticated process. You just throw up a term. I'm interested in China, machine learning, and gender. And the next person says, I'm interested in Italy and demography, right? And then we write a simple algorithm that matches people who are maximally similar and maximally dissimilar. And in this group of 30 people, there are already 13 disciplines represented. So it's pretty crazy, right? Some of these conversations fail right away, right? It's almost impossible for these people to imagine collaborating with each other. But every third or fourth interaction in our experience, which we've now been doing this for 7 or 8 years across many different places, we discovered that every fourth or fifth idea creates a tangible research idea. And then we put those up in a separate Google Doc, and by the end of the day, everybody's asked to join one project. And this is one of my favorite pictures in the history of computational social science as I've experienced it. These are the students on the first day of the second week where they had just begun to work on their projects. I was having dinner, and it was, I think, 11 or 11:30 at night by the time I trudged back to my hotel. And I walked by this room and saw the students working at 11:45 p.m. on the first day. This continued every night for 5 days. I don't know what that says about the field and our workaholicism, but I think really I mean it as an example of the palpable enthusiasm that people had. And it was one of these things where the idea to have the conference wasn't mine or Matt's. The projects that come out of the conference were not mine or Matt's. And even the idea of what to do next was not mine or Matt Selganik's. It was the extraordinarily smart and talented computer scientist Deborah Estrin, who alongside many other sort of leaders in the field like Duncan Watts and Gary King and others, Sandra Gonzalez-Bayon, had come to deliver lectures and sort of network with the students. And Professor Estrin said, this was great. Now you just need to do it all over the world. And much like the conference, where we had been asked to originally design this one event, we sort of looked at each other like, yeah, that's crazy. We're never going to do that. 2 weeks later, we're writing a grant application to the Alfred P. Sloan Foundation to fund 2 more institutes. And the idea was that we would stream all the lectures. This was before pre-COVID, so Zoom wasn't really a thing yet. The idea was to use the newly developed YouTube Live, and we would stream it to the other sites. And so we had sort of this idea that there would be a satellite model and that we would broadcast the lectures. We soon learned that that was silly for a number of reasons that I'll go into, which are further indication of the strength of the community and the power of the community to define the field. But we thought we were going to get 2 applications, and we got 8 applications. We funded 8 sites. The next year, we thought we were going to fund 15 sites, 10 sites, and we wound up funding 15 sites. And over 7 years, we eventually wound up with 52 locations around much of the world, except for Amsterdam. Not bitter, not bitter. Rotterdam has it in for you guys, though. It's a good group of people down there. Tom Emery, I don't know if people have connected with that group yet. I was just there for the Institute in June. So just, when I said we were silly to think about streaming our lectures, I really mean it, because what we discovered was, yes, they would occasionally stream one of our lectures, but more often they would recruit some talented person from whichever university where the event was being held. So for example, on the top left here, the University of Cape Town, where Viseho Ajuanu, who's on the lower left there, raised actually an additional $60,000 on top of the money we were able to give to him to bring students from all over sub-Saharan Africa to hear lectures from pioneering machine learning scholars at University of Cape Town. A number of amazing projects started there. On the top right is Istanbul. That's a Kiinan Ver, really amazing scholar who added so much richness and particularly pointed out some limitations in particularly the Western focus of our curriculum and the lack of examples from the rest of the world. Also translated all our content into a different programming language. And then on the bottom right, Hunter College in New York City. And I give these 3 examples. They're pretty different places because I want to underscore that, a lot of the places where we identified a need were not simply, a University of Amsterdam, a Stanford, an MIT, already elite organizations, but places where there really was no curriculum. And so people like Maria Rodriguez, who's on the lower right there, really created a whole culture, an institute that ran for several years there. Istanbul is actually our longest running site. It's been going for 5 years now. And as you'll soon see, Viseho's students are running that site in Nigeria that I just mentioned. So we now have a 4th generation site that came out of his singularly amazing effort. And so we really, we had no design to kind of spread internationally. It just happened very organically. So here we're looking at 2017 to 2023. And as you can see, we expanded particularly into sub-Saharan Africa, much of Europe. We could do much better in South America and Northern Africa, many other parts of the world. But we've run campuses, especially pre the invasion of Ukraine, in Moscow, in Beijing, in Monterrey, Mexico, in Sydney, Australia, many different diverse places. And principally, as you'll see, these were run by alumni of the program. Okay, talking a lot about the program and not a lot about the field. So I want to get back to what the field is and why I think this community is a good way to look at it. Here we're looking at the disciplinary background of participants in this program over its first 5 years. And we have here already, just about 24 fields. And these are only fields which sent at least 5 participants. So if we measure all fields and the way that people sort of describe their field, we have 123 fields represented in this program. I did not even know there were 123 fields. I'm a little skeptical. Some of them are probably overlapping, right? But I think it's a testament to the sheer diversity of the field, and how much the original focus on, say, sociology and computer science morphed into everyone from lawyers and legal scholars to education scholars to public health scholars to statisticians. And really, I think the disciplinary diversity is one of the key indicators of the health of a field. raises other questions. One of the reasons I'm so reluctant to define computational social science is it has to please everyone in all of these fields, right? And I think the field, as I'll mention at the end, is on the brink of a bit of an identity crisis, because if we become like the comparative historical scholar Kathy Taylor said of institutions, to the point where she was saying of institutions, that institutions can explain so much that they actually explain nothing at all. And I think the same could be said of computational social science. We're really stretching the boundary of the field, and we really need to think about where its soul is and whether we have a single set of motivating ideas. I'll try to articulate those at the end, but I feel a little bit unworthy to do that given the diversity here. We're also very proud of the demographic diversity of this field. So more than half of the participants self-identify as female. Less than half self-identify as white or European. And now more than 2,500 people have been through the program in these 52 locations around the world. And this is, I think, one of the real amazing signs of the evolution of the field, is that each generation of scholars has redefined it. So Visiho, who I mentioned earlier, had two students, Emmanuel and Malibo, who separately founded two institutes in Johannesburg, near Cape Town, also in a different part of Nigeria than the one that we were looking at the beginning of the lecture, and most recently in Ghana and University of Calabar. And this story alone is a testament to Visiho's amazing skill in not only being a fine scholar. He does remarkable work on demography and computational social science, looking at questions of fertility and family planning, particularly outside the US and Europe, using computational methods like natural language processing, social media data, and other tools. But the really cool thing is that his students are similarly innovative and different than him. So Juliet, who's leading the Calabar site, is applying natural language processing to consumer behavior. And Malibo is applying it to issues of gender in the field of communications. And the amazing thing is that this story has played out again and again and again. So at the top of this impossible to read figure here, if you want to explore it on your own, you can visit the website, which I'll link at the end, which is sicss.io, SICSS.io. But basically what you can see is the original sites at Princeton and Duke at the top there, and then the first generation sites, those were students who were at those sites, and then the purple sites are those students, and the blue sites are those students starting an institute. So why do I keep going on about this program? Why am I reluctant to define computational social science? It's because this program really, I think, has done it for us. So when I said earlier that this started out as a satellite idea, that we were going to stream our lectures all over the world, we very quickly discovered that we had a lot to learn from everyone else. And today, the curriculum, which is I'll show in a minute, is fully open source and available to anyone. There's actually 600 people who contribute to the curriculum every year. So this is why it's so hard to put your finger on the pulse of the field or talk about its soul. Let's get into some more of the content of what people in the field are studying. And I think it's useful to look at young scholars, because if we look at young scholars and what they're studying, we get some sense of where we're going, I hope. And these are from the expressed research interests of the participants in the program when we onboard them. Unsurprisingly, social media, psychology, politics, health, machine learning, opinion mining, text, technology, misinformation. Many of these will be familiar to all of you. And the research projects, too, similarly diverse in their applications and interests. Everything from methodological applications of regression trees and techniques for detecting causal heterogeneity to studies of gender and bias in AI, which I'll tell you about in just a minute. Okay, so the program's going great. We're very happy with it. And then, like everyone else, COVID. Matt and I had a conversation. It was, I think, our third or fourth year in. And we thought, how on earth can we bring people from all over the world into one place? The risk alone, it's just unconscionable. We got to shut the program down. And as Matt liked to say, the show must go on. And so we retreated to the attics of our respective houses and recorded 12 hours of video content, which formed the basis of the lectures for that year. And we thought this was a one-off thing. Like, we wouldn't need to, talk much more than that, and hopefully we would never be wannabe YouTube stars again. But that didn't happen. So we realized that we weren't the only people making these videos. In fact, many of you, I'm sure, were teaching classes or in classes where you're learning about cutting edge stuff. And one of the amazing things about this field is, the methodological innovation is so rapid that it's really hard to keep up. I mean, for myself included. And I was amazed when only 2 years into the program, we had more than 6 days of video content created by more than 15 people. And so if you check this out, if you're a student or if you're new to the field and want to learn about sort of either basic concepts, there's everything from a beginner's bootcamp curriculum to lectures on how to do experiments with generative AI, which, as I'll tell you about in a minute, I think is part of the future of the field. And a further indication of the health and growth of the field is that a lot of people seem to use it. So more than 250,000 people have used the website, 170,000 have viewed our YouTube videos, and our website, which again is an open source curriculum which any of you can contribute to or contribute videos to, has been constructed through the joint work of 500 people making 16,500 GitHub commits, which is essentially a change to the website. The work has also grown organically from the community. I'm just cherry picking 2 wonderful examples that I could have picked many more. They're all cherries. The one on the left is a collaboration between a computer scientist, an information scientist, a political scientist, and a sociologist who jointly decided to study how some of the first image APIs, specifically Microsoft and Google's tools, which were then, this was 2018, just being rolled out. We didn't know what we know now about the potential for bias in machine learning. We knew a little bit about it, but we didn't have very good examples of it. And so this very clever idea to scrape the pictures posted by a large group of politicians in the United States and then ask the tools, both the Microsoft tool and the Google tool, to annotate the images, and discovered pretty quickly, and now it probably won't surprise you to know, that there was significant gender bias. Women were depicted and described principally in terms of their physical characteristics, and men were given tags like leader or presidential and things of that nature. And so it was one of the first large projects to document this. Another project which appeared in the Proceedings of the National Academy of Science, a wonderful journal, identified how the wisdom of crowds phenomenon could be applied to solve a variety of dilemmas in the field of politics. And that was a joint collaboration by a computer scientist, a sociologist, and a political scientist. Just wonderfully diverse projects. I'm not showing you all the ones that failed, right? A lot of them failed. And I want to say something quick about failure, which I learned from Matt Selganek, the co-founder of this program, which is that we learn through failure. And I think particularly as those of us who are older faculty in the room are confronting ChatGPT in the classroom, it's really important for us to reflect upon how we're going to learn, right? How we're just going to sort of, do we want students just to rehearse facts and do we want to just lecture? And I would argue that, attempting a project that ultimately fails, like a lot more can be learned in that setting than I realized at first. And so I think even our projects that have failed have had some pedagogical value. Another really wonderful thing about the field and this program is that it hasn't just produced academic research. It's produced other collective goods, like Very CSS, which is a program created by my student Taylor Brown and Tina Long at Northwestern, which is a directory of non-white and non-male scholars in the field, designed to diversify the field. So you can check out that wonderfully growing community there. The academic Twitter package, which many of you maybe have used to access Twitter data. Remember Twitter data, back when we could get it? That was developed at SIX Oxford. And Empirica, which is one of the leading tools for online experimentation right now, was also hatched at SIX Princeton in 2017 by Abdullah Al-Matouk. And one of the fun things about preparing for this lecture is I could try to see, okay, where's everybody at now? You know, it's kind of like a behind the music thing, you know, where you go back, who's doing what now. And I was just amazed when I tracked down the career trajectories of these people who I showed you at the outset. So we've got, you know, I mean, all just amazing, you know, leaders in the field in so many different disciplines. Again, 13 different disciplines represented in this group alone. And also importantly, and this will be a theme as we get into the future and upcoming challenges, people both in academic positions and non-academic positions. And one of my great concerns, as I'll mention in a few minutes, is that we're not building those bridges quickly and urgently enough. Okay. So where are we headed? You know, one of the things we've learned as computational social scientists, I would argue, is that we're terrible at predicting the future. So if you're familiar with the Fragile Families Challenge, this is an amazing project devised by the aforementioned Matt Salganik, where he basically structured a survey to be released, sort of half of the survey to be released, and he would allow scholars to assemble teams and develop machine learning models to predict the held out outcomes, the data that weren't released. And then there would be a competition and a leaderboard, much like, you know, you're probably familiar with the Netflix prize, which is a competition where teams earn money for producing the best quality predictions of what movies people might like. So the thought experiment was like, let's do this with social science and let's see what happens. And the depressing conclusion of the more than 200 scholars who participated in this challenge was that the very best model did very slightly better than a logistic regression model from 1942, right? So yeah, predicting the future, it's dangerous business, especially for a field as diverse as this. But we'll start here. So, you know, careful viewers of the first slide will have noticed the digital watermark at the lower right there, a painting of computational social science in the style of Banksy. I'm sure many of you have played with these text-to-image tools like DALL-E or Stable Diffusion, and they're a wonderful example of generative AI. And of the many things I thought I could talk about and where, in terms of where the field was going, I simply concluded that this is just a completely unignorable development. You know, this major transformation, you know, hatched at Google in 2017 with the advent of the transformer model, which really shifted the capabilities of machine learning, I would argue, from being really good at pattern detection, maybe not causal inference and prediction in social settings, but in many other settings. But, you know, tools like topic modeling or word embeddings, which many of us use to detect patterns in, say, texts in order to identify cultural themes, to the ability to create, you know, remarkably human-like outputs, text, images, music, now videos, and many other cultural products. And so a lot of what I've been doing in the last 3 years, and will do tomorrow morning when I wake up to work, is thinking about how generative AI will reshape computational social science. And if you want a really long-winded answer to this question, you can check out this paper, which is linked on my website, which I'll link at the end, which is called Can Generative AI Improve Social Science? And the reason it's a can and not how is because I'm not yet convinced it's going to be easy. But before we get to the challenges, let's talk about how generative AI might change a number of different parts of social science. First, you know, hopefully pretty easy to accomplish application would be to use generative AI to create synthetic images, vignettes, and other texts within, say, survey experiments. So, you know, often we have the challenge when we are, say, trying to if an economist is trying to measure, yes, economists are computational social scientists too. If we're trying to measure the effect of skin color on, say, whether someone is hired, the ideal sort of survey experiment might show two otherwise identical people, but with slightly different skin tone, right? And now through generative AI, this is a pretty trivial thing to do. Another really remarkable application that I think is one of the coolest applications of generative AI in social science so far is the various research groups who have now demonstrated that generative AI is really good at impersonating survey populations. So if we ask large language models to answer questions in large representative surveys, such as the American National Election Study, we've seen, in fact, now across 73 different surveys, that it can reproduce major subgroups, especially with a little bit of fine-tuning or tweaking, with pretty remarkable precision. Some people are taking this so far as to say that we don't need to do surveys anymore. I think that's a little crazy. I don't think we can do away with human respondents that quickly. But it does raise really interesting opportunities. We can estimate how a population might react in less than an hour, depending on how fast the large language model is. We can simulate arguably more diverse populations that we might have at, say, a university, right? A lot of research is done using 100 university students, who, as we all know, are not always the most diverse populations. We can test dangerous or even unethical research questions and hypotheses with large language models, opening up a whole new area of research in things like how to dissuade people from sharing misinformation when we know that some of the interventions that we might like to do could backfire and cause people to sort of reinforce misinformation or spread it further. A second area which I'm really excited about, and I know from meeting many of you over the last year are really excited about, is automated text analysis. So I'll give a shout out to Petter Tornberg, who has a wonderful paper, which is sort of a how-to guide for using a large language model to do automated content analysis. But now, not only Petter, but many other scholars in this field have shown that large language models are pretty good coders. Maybe arguably not quite as good as a highly trained expert coder, but probably at least as good and probably better than a crowdsourced worker or a relatively untrained worker. Now, how does it work? Well, essentially, you would take a qualitative codebook like you might use in any kind of content analysis or even coding in-depth interviews, and you give the model as a prompt, the set of instructions it's meant to respond to. You give the model the codebook, and then you give it a text, and you say, apply the codes in this codebook to the text. And there's variation, and if you're interested in the variation, there's a number of wonderful studies that look at this across 30 or 40 different annotated data sets in various fields that show, overall, it's pretty good. Maybe not as good as a fine-tuned BERT model, for those of you who are familiar with that family of techniques, but still very good. And as we all know, the models seem to be getting better. So maybe this opens up a whole new line of research in automated text analysis. And again, as we're thinking about the trade-offs here, is it going to make mistakes? Yes. Is it going to show bias? Yes. I want to talk about that when we get to challenges. But there's also huge upside. If we think about a virtual research assistant who's able to code 3,000 documents in a day in 22 different languages, right? It opens up a lot of questions. We need to kick the tires, meaning we need to test the techniques and validate them a lot more than we have. But if they continue to perform as well as they have in these preliminary studies, it's a really exciting opportunity to advance a lot of research, especially the type of research I like to do on culture at aggregate levels of analysis. The third one, I'm going to give a worked example in just a minute, so I'll briefly say another really exciting application is agent-based models. So the older social scientists in the room will remember agent-based models had a bit of a moment in social science in the 70s and 80s especially, and these are models where we create synthetic social structures and agents who navigate them, and typically in before large language models, often these actors would follow relatively simplistic rules that were meant to approximate human behavior, right? It's not as if the point of the models was to perfectly reproduce human behavior, but the idea was that we can simulate emergent patterns of group behavior, right? We can simulate, for example, residential segregation using a Schelling model, or we can simulate political polarization using numerous different models that were developed for that point. So, they had a moment, and I think the moment, it's not like they went away, but a lot of people, I think, reasonably argued that agent-based models lacked realism. They weren't really able to communicate, right? And if we think about most human behavior, especially the type of human behavior that a sociologist, a social psychologist, or a communication scholar might develop as a theory, usually humans don't follow rules, right? And the interesting stuff is usually about why people don't follow the rules they're supposed to, or how people reinvent the rules. And here, I think large language models have an enormous potential to improve agent-based models. Already, a team at Stanford about a year ago created a toy simulation with 16 different large language models and gave them totally arbitrary, frankly ridiculous roles for social scientists, things like this is a pharmacist who's gregarious, who has 2 children, and this is a student who likes music, and so on and so forth. And they just let the simulation run. They gave the agents a working memory by allowing the model to periodically summarize previous interactions that the agents have had. They talked to each other. Within days, all of the agents developed a daily routine. Within a week, one of the agents had decided to host a Valentine's Day party. The next day, another one of the agents asked another one of the agents out on a date to the party, and everybody else started gossiping about what was happening, right? Pretty plausible. A toy example, and one that we would need to improve upon if we're going to test serious social science theories, but a really nice proof of concept that these models can demonstrate emergent behavior like gossip. Another big one, earlier when I mentioned this continuum from theory to methods, right? One thing that characterized the early days of computational social science was it was really, really hard to get access to training. You either had to go into like a computer science curriculum where you would learn things like systems architecture that are totally, not very useful to a social scientist, or you'd just sort of have to hack things together on your own. And it was terrible. Lots of mistakes were made. It certainly wasn't efficient. And now another way that I think generative AI is, we're all seeing it change things, especially with tools like Autopilot and the OpenAI's Codex tool. It can produce code. Often the code has bugs, and there's problems with that. Sometimes finding the bug is more frustrating than writing the code from scratch. But I'm finding in teaching that it's particularly useful if people are trying to debug their own code, asking a large language model like ChatGPT, why isn't my code working? Or if they encounter code they're unfamiliar with, asking the model to explain what's happening, right? Even if it's not always perfect, it's a lot better than a Google search. And I think it will open up the skills of coding, which have already been becoming more accessible for many years now. So I think we could see pedagogical changes that might even change the career incentives of a lot of people. Writing, I think most of us have experienced its use as writing, particularly useful for people writing in another language, of course, but also, interestingly, I think it can be used to identify our own blind spots in writing. So one thing I've gotten in the habit of doing is asking ChatGPT, try to come up with 3 reasons why I'm wrong, and then thinking about possible objections to one's arguments, I think one could argue is a useful way of writing. This one's a bit crazy, but might it help us ask research questions? Large language models are really great at identifying patterns and answering questions, right, singular questions. And if they're trained on an academic corpus like the Web of Science, there's a number of interesting tools out there now which suggest that they can be very useful for running a meta-analysis, doing the preliminary stages of a literature review. I don't think they're up to the task of wholly outsourcing literature review, nowhere near. Again, it's like B+ work, not A+ work, but probably good enough for those who are just beginning to start out reading and trying to focus their reading. Large-scale experiments with groups. So I was mentioning agent-based models. There's a lot of new opportunities for looking at group behavior, but we can also use those simulations as part of experiments. So one of the things we're doing in the Duke Polarization Lab right now is creating something we call the Social Media Accelerator. And this is a large, soon-to-be open-source environment where scholars can create simulated social media settings populated by automated agents and then pay human respondents to interact with them. And this opens up, I think, a lot of deeply sociological questions, social science questions about group behavior. It's enormously expensive to recruit a group of people to participate in a group experiment, and there's non-compliance, and people can't be herded into every treatment condition or sometimes don't comply with the treatments we're trying to give them. But bots, especially bots that are prompted effectively to simulate real human populations, maybe even using real social media data or data from surveys like the survey taking bots I mentioned earlier, I think there's real potential to look at group level experiments. And lastly, given the capacity of these models for language, I think there's a really potent moment for experimentation on culture, by which I mean a meaning making. I won't try to define culture. Ashley and I once tried to write a book about measuring culture, and Ashley wisely left the project because it was so darn hard, so I won't try it here. But basically what I'm saying is we need a way of studying large-scale interventions in the cultural realm, and maybe large language models can help us create group-level treatments in the creation of meaning systems. And I think that's one that is particularly exciting. Finally, on the opportunity side, I just want to share a really wonderful project that I've been able to start here with Petter Diliara and Eustace here. And this is sort of an application of what I was just talking about. We are trying to use large language models to create a simulated social media platform and prototype alternative newsfeed algorithms that might reduce political polarization. So these agents are prompted using the American National Election Study. We give them hobbies and habits and names. And as you'll see when we're done with the paper, which will hopefully be soon, they come up with extraordinarily plausible behavior. And we're able to test interventions like, for example, the idea that algorithms could reward consensus instead of engagement, something known as a bridging algorithm. And we have some preliminary evidence that that intervention might work, at least on this synthetic population. And even if you're uncomfortable, like I suspect many of you are, with the idea that we can take away from that, say Facebook should go do this. I wouldn't say that personally. I don't know my co-authors, but at least it helps us, prune the possibility space of where to focus our microscopes, so to speak, in order to identify promising experiments to run. So long story short, I think generative AI is going to profoundly reshape the way we think about theory and methods. I think we're going to largely do away with this typology as methods become more accessible to many, but also as the deeper theoretical questions, like the questions that motivated me, I think become more available for the large-scale experimentation that computational social science is really known for. So I think in many ways, this is a new day for qualitative research. I was joking with a dean of a major university recently, and I was telling this dean about prompt engineering. It was early days of generative AI, and those of you who know the field will know that prompt engineering is essentially telling the model what to do, right, using language. And the dean was like, so basically you need people who are really good at understanding how humans use language in context. And I was like, yeah. He's like, so this is going to save the humanities. And I was like, well, okay, well, I don't know, but it's an example. I think it's not a crazy idea, right, to think that a lot of what we'll be doing is reverse engineering these models, given that nobody knows really how they work. And cultural insights, especially because they're language-based, are going to be a key way we're going to do that, I would predict. Okay. Now, all the challenges. There's many. Data access. As many of you know, Twitter data now costs $42,000 a month. Reddit recently followed Twitter's lead. shutting down access, presumably out of recognition of the value of their data as training data for the aforementioned large language models. So, so we just don't have access to the data or the models. Career incentives, there's an academic brain drain that we're all experiencing. And earlier when I mentioned we need to build stronger ties between computational social science in academia and industry, this is what I was worried about. The danger that we will spread misinformation about social science, right? If we have models creating and navigating the literature, right, we could wind up with misinformation like this. Bias, a huge issue, and I'm running short on time, so I want to wrap up. This is an issue many of us are well aware of, right? The tendency of these models to exhibit bias and prejudice. Now, this is deeply concerning if we're thinking about letting these tools out into the wild. And here I asked Ali for a picture of a doctor. It shows a male doctor, because it's learned through cultural biases that there's a bias against women in many fields of medicine. But it's interesting, and I think we should ask ourselves, is this a useful bias for social science too? Because very often we want to recreate biases and study their effect in social settings. So it could be both a problem and an opportunity. But there's another problem, which these tools also exhibit the biases of the people who develop them, which is to say largely white men from Silicon Valley. And sometimes they've trained out the most interesting, more scientifically interesting bias, and that raises another set of questions for all of us. Lack of ethical guidelines. Many of us are sort of flying blind and asking questions about, what does informed consent mean in the era of generative AI? What will be the Cambridge Analytica moment for generative AI? And I think, we have to think about unknown unknowns, and we have to go beyond what institutional review boards require of us to study possible ethical challenges. Okay, really need to wrap up. Charting a path forward. I spent so much time talking about the Summer Institutes in Computational Social Science because I deeply believe that diversity is our strength in this field. We need to continue to cultivate it. It doesn't happen on its own. We need major institutional investments to do it. We need to promote lateral interdisciplinary connections at early career stages, especially the stages of many of you in this room. We need to create shared research infrastructure as data becomes increasingly centralized within large corporations, and also the tools to analyze that data, like large language models, becomes increasingly concentrated within large corporations. We need to explore and identify opportunities to create new research infrastructure to continue to ensure that particularly generative AI evolves with the interests of social science in mind. I think personally we should prioritize solution-oriented research. I don't think we shouldn't do science for science's sake, but I think prioritizing solution-oriented research has the happy byproduct of improving public understanding of the value of computational social sciences. And as I mentioned, I think the future is not only quantitative, but also qualitative, and thinking about new ways to build those bridges, which is why I'm particularly excited to hear what Ashley thinks about these ideas. So thank you so much.
Yeah, great, thank you. Oh, it's on, okay, good. Good.
It's comfy.
It's a comfy chair. Yeah. Thank you. Okay, great. So yes, as mentioned, I'm an ethnographer, and I thought maybe I would open our discussion with some of our shared interests around method, come to this question of bias, and think a little bit about parallel problems that we have in qualitative social sciences compared to computational social sciences, and where you see them, similar and different. By the way, I asked ChatGPT, what does Chris Bale think about qualitative social sciences? Yeah, it was apparently nothing. Yeah, there's not much going on, but I know that that's not true. So maybe I could introduce a little bit of ethnography and the sort of founding story of the American ethnographic tradition in which I was trained. So it starts in the early mid 20th centuries with the Chicago School, people like Robert Park and affiliates like Jane Addams are encouraging young scholars to go out into the world and discover the city and discover how communities are kind of cohering through shared meanings. Really the idea was to put the urban into a sort of microscope through detailed in-person observation. Yeah. And we get lots of kind of great studies about what's going on in the jazz club or what's going on in the taxi dance hall. And it's about how cities kind of cohere. Okay, so it turns out, though, that lots of those studies were fundamentally flawed through the kind of interpretive bias that any observer brings when she looks into the social world. And these biases were also called out by the other founder of American sociology, W.E.B. Du Bois, who his knowledge, particularly about Black communities and marginalized communities, really went up against what people in the Chicago studies were finding. Okay, so his voice gets suppressed because we know how knowledge is shaped by power. But yeah, that's the sort of problem of ethnography that we know we have tools of how to deal with interpretation, the limitations of our interpretation, the problem of transparency. Okay, so Chris Bale, you're looking at culture from 30,000 feet. And yeah, how do you deal with those problems?
It's really the most important question, I think, for us all to ask right now, because there are limits. You know, I'm an optimist. I think I get a little too excited about some of the positives here, but I think just hearing what you said about the in-person observation, right? Any research we do with these types of tools that I'm talking about would rely upon the assumption that we can get the data, right? Like, which is not just it's more than just, I think you would argue, knowing your work really well, that it's more than just like a video, right? Which in some sense, you'd love to have, even introducing a video camera into, for example, the situations you study would change people's behavior, right? Yeah. But even if we had the video as a thought experiment, I think you'd agree it still wouldn't be enough, right? We still would, what's outside the camera frame? Who is the camera pointing at, right? There's social bias and social processes shaping each of these things. So certainly, I think there's, I don't think we'll ever have tools that would even do a poor impersonation of an ethnographer. However, I think like the opportunity to use ethnography in tandem with these methods is really intriguing. So I'll give a shout out to Eustace in his new book with John Boy, which is a really brilliant combination of ethnographic observation of people using Instagram, but also very high-powered, GIS analysis of Instagram patterns of usage, and probing questions about, one of our shared academic heroes, Norbert Elias, deep questions about status that just don't reveal themselves unless you are observing. I think Eustace would agree, these interactions. So I think you're definitely right. There's limits, and I think finding those limits should be one of the first tasks. But I'd love to see more of the hybrid work.
Mm-hmm. To get into the nitty gritty, when we're writing ethnography or any kind of qualitative social science research, say in the methodological appendix, we always have to account for like our own positionality is one. I mean that. It doesn't solve the problem, but it acknowledges the potential problems, because it's true, every way of seeing is also a way of not seeing, yeah? And our vision is shaped by all of these different intersectional positions that we occupy. So do you do that?
I try. I do a little bit of this hybrid research. So in the book that Eustace mentioned at the outset, I did a large-scale experiment with Twitter users where we exposed Twitter users to people who don't agree with them, and we did a large-scale, quantitative study, and it's some interesting findings and a lot of data. I think we once collected the number of data points, and it was in the tens of millions. When you think about all the network data and all the text data and all the other things you can collect from, or used to be able to collect from Twitter, when we went to make sense of this puzzling finding, we came up totally short. We didn't have answers. We had, a bunch of speculation, but that didn't work out either. And by far the most revelatory point in the research process was when we decided to do a qualitative field experiment. So we went out and interviewed people. We did the same experiment, but this time we interviewed people before and after. These were longitudinal qualitative interviews with about 80 people. And that was by far the biggest point of theoretical progress in the book. Mm-hmm. But now I'm left wondering, what even that left out. Like had I been in their houses with them, right? Which maybe I don't, maybe that would be the most boring ethnography ever, watching people use social media. But I think it's the type of question that again, we should ask because I got the type of data I got is what someone wants a researcher like me to hear, not the, I even with that level of data, I can't get at the what people say versus what people do kind of trade-off that an ethnographer could.
Mm-hmm, mm-hmm. Yeah, I really love that book. We read it with my students last week, and they were really into it, and they were also like perplexed because they were like, how do we get all huge populations to read this book to understand what is actually happening in these dynamics? And I think that there's I don't know. On the one hand, I would think that disseminating research, because it's computational social science, it has this greater authority and objectivity of numbers because of the spectacle of big data or big numbers, that it might be, I don't know, more headline grabbing, that you have more access to disseminate your findings. On the other hand, it's quite nuanced, your work. And I don't know, like what's your vision for how to connect and disseminate and communicate?
When I was, joking earlier about the dean and the humanities, like I was only half joking. I do think, reverse engineering large language models through qualitative methods is a super interesting place to begin to answer this question, right? In large part because the mythology around AI is so powerful right now. Like if you look at public opinion of artificial intelligence, people think it can do it all. And we, many of us know it can, right? And many of us are keenly aware of things like bias and all the training process and why we can't outsource most important things we do to AI, and yet that message isn't getting out, right? What's getting out is, oh, guess what ChatGPT can do, right? Mm-hmm. Guess what Bard can do, and so I think like we're about predicting a future again, dangerous business here. But my general sense is we're at the peak of expectations for AI, and we're about to come crashing down. We're about to realize just how often and in how many places these things fail. And as people try to do practical things, they'll realize the limitations of AI. And I hope this is a moment for qualitative research to come in and explain why, especially, an ethnography I would love to read, and I know some of these are being written, and some of your work, even your newer work, I think will touch on some of this, but like how people interact with AI, like, the influencers I know you're studying, right, and how they interact with a TikTok algorithm, is like super fascinating and important here.
Yeah. Cool, thanks. It's somewhat of a non sequitur, but I couldn't help notice in your remarks. On the one hand, you've got this awesome global, diverse network tapping into young scholars for computational social sciences all around the world, and on the other hand, there's a lot of work that gets in the spotlight that is being referenced from Stanford, for instance. You're at Duke, right? Like, so this is a total curveball question, but like with computational social sciences, you must have thought about like the future of institutions of higher education, and what's the direction that you would hope for or that you see? Yeah,
it's a really good question. I view this as an opportunity to try to correct past inequalities. A lot of the work I do in the sort of institutional level is with the U.S. National Science Foundation, and as part of the advisory committee for the foundation, I've been on a committee called Build and Broaden, which has the explicit mission of basically broadening access to things like grant funding from the National Science Foundation. And they're always asking the question, how do we get these historically underserved universities that are much vastly less wealthy than the institutions you just mentioned. How do we get them ahead? And this had a huge impact on me and some of the other members of the council, and it inspired me in the last 3 years to intentionally do outreach to non-elite organizations. So now I'm proud to say for 2 years we've run a site at North Dakota State University. For 3 years we've run a site at Howard University, which is a historically black college and university in the United States. We ran a site at Georgia State University this year, at Florida Atlantic University. For those of you not from the US, these are not elite universities, but they're places that won't get a computational social scientist for maybe 10, 20 years. So if we can train people there, I think that's why, and not just for the point of expanding access, but also for improving the science. Like if we're gonna be serious about tackling bias, I mean, as a Duke professor and middle-aged white male, I'm just simply not going to see bias in data in the same way that some of the students I was just mentioning will. So, for my money, there's a moral imperative, there's an institutional imperative, but there's also a scientific one. And we know the wisdom of crowds, right? For the card-carrying network theorists here, right? It improves science. We've seen it in citation patterns, the work of Brian Uzi and others. So, I think there's every reason to do it, and we need to do it more often.
Yeah. Nice. So, just a point of clarification. So you said that we don't say big data anymore. Yeah? What happened?
That's a really good question.
I just was curious.
Yeah, I had this T-shirt. It had a great joke. It was I was into data before it was big. But now nobody knows
edgy.
the joke, right? Yeah, so it's a big problem for me because it's my favorite T-shirt. Yeah, the deeper problems in life, really. Yeah, it's a good question. It really just kind of went out of vogue. I think for me, the main reason was, it was really more than just the size of the data, right? The size of the data is great, but if you have fundamental problems of causal inference, and you have more data, it doesn't necessarily make them better. If you have biased data and just more data, you're going to still have biased conclusions, right? And, I think it also belied some of the depth of the data, even though, as we were saying earlier, this data, can't even approximate, a lot of the social context, a marquee ethnographer like yourself would see. But it's also a lot more than the type of data that was available, like when you and I were in grad school. Like I remember as a young scholar thinking, okay, well, there's like 5 surveys I can write my dissertation about, right? Yeah. Or I can do in-depth interviews, and then there was this massive middle space that opened up, and so I think part of the reason why we've sort of jettisoned that, the term is just it's so much more than the size of the data, and now especially with generative AI, I think like the size of the data is just taken for granted. Like there's data everywhere, except for Twitter and Reddit, so really it's about rethinking theory. It's come full circle. Like we're back to okay, yeah, we got the data, but now what are we going to do? So that's my take, but I don't have a etymology, that's more sophisticated than that.
No, it's nice. I was remembering this little essay by the sociologist Jen Schrady that big data are actually small. Because if you think of Twitter, I think it's like the top 25% of people are driving all the posts, and the 75% are having no posts at all. So it's like some voices are obviously steering the ship.
Yeah, and Zeynep Tufekci, who I know is going to be one of the future lecturers here, wrote a really great piece and a similar with a similar kind of argument, which is that Twitter has sort of become the model organism for computational social science, and it's a weird place, right? Yeah. It does not only, you're right, in fact, the data I'm familiar with are a little more extreme, like 6% of people make up 76% of tweets about politics, for example, and so if we study a political debate, we're really, according to at least a lot of our qualitative research, just studying extremists yelling at each other, right? And, Twitter is also just unusual in the landscape of social media too, right? Like, it's not the most popular social media site by far, right? It's barely in the top 10, especially now. And, the largest platforms right now, TikTok, if we call YouTube a social media site, which I know is controversial, but if you count YouTube, right, or Facebook or Meta, we or Instagram, we know so little about these places because they don't share data.
Yeah.
So I think Jen Schrady, who's a wonderful sociologist at Sciences Po in Paris, for those of you who don't know, is right. It really is a big problem. We're seeing, digital exhaust instead of, the perfect record of human behavior that we might like.
Mm-hmm. So just if I could have just one more closing question, because I always like this one to hear. Advice that you would give to somebody in grad school who's maybe thinking about going in this direction. Yeah.
Wow. Yeah, it's a great question. I think, one thing I really believe that we need more, we need to enable creativity and imagination at a level that we don't typically do. And I think I, like many young graduate students, had this idea that you sit around and then eventually an apple falls on your head and you say something smart, right?
It did happen before.
It happened once, the one time, right? But for the rest of us, it doesn't happen, right? And it's more about exploration and the process of exploration. And you realize that, it's like riding a bicycle. Like, in order to keep your balance, you have to keep moving, right? We all know this quote. And so for me, I think, I would argue that even someone who has very little interest in, the computational side of things could be well served just by taking a survey course or maybe coming to one of our institutes. And the reason is this: I think just that it opens up the space of possibilities. Even if it's not your thing, it opens up a broader menu of research topics and modalities. And also, I think, and here I think I'm biased, but I think if this field keeps growing like it is, and we're seeing, parallel trends in the rest of academia too, right? Like the way that coding is spreading into medicine, or any other field we could think about, right? You could argue it's kind of like a new moment for the liberal arts education too, right? That being fluent in the issues of our time requires some familiarity with code and how AI works. So I would argue that it should, I think I'd stop short of making it a mandatory class, but I do think it could open a lot of doors for people like me who never thought they would wind up in the field, and just kept on pulling a string and somehow found themselves giving a talk called "The Past, Present, and Future of Computational Social Science." So
Beautiful.
there you go.
That's great. Okay, good.
Thank you.